Students, welcome to Unit 5, Right Triangles, Lesson 5.3, SOH CAH TOA. By far the most important lesson of the entire year. You can look here. Don't forget to give me time, date, and location that you're working with here. Let's do a quick review of things that we have been doing. This is something we need to start learning how to use. It's called the Right Triangle Toolbox. It is a hot pink colored sheet in your reference booklets. It's called the Right Triangle Toolbox, and it's based on these three words: have, need, do. Have, need, do. Have, need, and then you do this. So there's 5 different tools that you're going to be learning to use for right triangle. Here's 3 of them: Pythagorean theorem, 45, 45, 90, and 30, 60, 90. You have 3 of the 5 under your belt so far. The main question you have to be able to answer is, when you have a right triangle, which one of these tools do you use? That's very critical. And the choice of which tool to use depends on what you have and what you need. So if you have 2 sides and you need a 3rd side, you do Pythagorean theorem. If you have 2 sides, you need a 3rd side, you do Pythagorean theorem. If you have a right triangle with a 45-degree angle, you do the 45, 45, 90, leg, 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 root 2. 45, 45, 90, leg, 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 root 2. If you have a right triangle, you need to change this to with a 30 or 60-degree angle. Then you have a 30, 60, 90, which goes 30, 60, 90, short leg, root 3, short leg times 2. Now let me give you an example. So we ask ourselves here, we have 2 sides of a right triangle. 1, 2. We have 2 sides. We need the 3rd side. So what do? We do have 2 sides, need 3rd side. That's Pythagorean theorem. Let's go ahead and label that. Let's label our legs. And we know this. We know leg squared. Let's leg squared equals hypo squared. Let me label our hypo here. And now we circle, plug, chug. Circle, circle, and we're going to solve. X squared equals 36. The opposite of squaring is square rooting. So here, x equals, 6. So this is a 6, 8, 10 right triangle. Now over here, we don't have 2 sides. We only have 1 side. So let's look at what we have. We have a 30, 60, 90 triangle. Why? How do I know that? That's 90, that's 30, that has to be 60. And we need a side. So we write down what we do. And it goes short leg root 3, short leg times 2. So you always start with the short leg in a 30, 60, 90. So you identify the short leg is across the smaller angle, which is the 30. So you start by labeling the short leg. Then we're going to get the short leg to the hypo was times by 2. Short leg to the long leg, we times by root 3. So this reads like this. The short leg, whatever it is, times 2 gives us the hypo. You have to work backwards. Something times 2 equals 12. And of course, our something is 6. 6 times 2. So our short leg is 6 here. And then 6 times root 3, this is just 6 root 3, and we are done. So the key 3 words you need to watch out for: have, need, do. Have, need, do. This right triangle toolbox that's in your reference booklet, you must memorize these. You heard me right, folks. You actually have to memorize something. So today, by the time we're finished, you need to make sure you have your scientific calculator here with you. Colors are going to be helpful. Pencil. You're going to understand the word trigonometry, which this is an introduction to. Something called the sine ratio, the cosine ratio, tangent ratio. So the difference between a leg and a hypotenuse. So what have we learned so far? Pythagorean theorem. And we use this when you have 2 sides, you need a 3rd side. 45, 45, 90. And we use this when we have a 45, 45, 90 triangle. And only when we have a 45, 45, 90. 30, 60, 90. We use this when we have a 30, 60, 90 triangle. And only when you have a 30, 60, 90 triangle. You can't use those tables for any other kind of triangle. So the question is this: what if you have angles that are not 45 or 30 or 60? What if you have a triangle that looks like this? Got a right angle here, and let's say this angle is 39 degrees, and you have an unknown, and let's say the hypo is 10. Now what do you do? So when the angles are not 45, 30, or 60, you're going to be using these ratios called sine, cosine, and tangent. Now, those are fancy words for something super simple. Don't let this freak you out. In fact, right now, let's get this out of the way. All 3 of these, all they are ratios, right? Behold, a ratio. You know them as fractions. It's okay. You've seen this before, I promise. Now, in order to use the ratios, you must first learn how to label a right triangle with these terms: hypotenuse, opposite, and adjacent. Very important that you're able to use these terms. Now, the hypotenuse and everything is respect to what's called a chosen angle. The chosen angle in trig, we call that theta. That is the Greek letter theta. It represents an angle. So I'm going to show you how to do one. Ready? So if this is our theta, step 1, you always find the hypo. That's easy. The right angle points to the hypo. Hypo is always hypo. That never changes. However, when the theta changes, what defines opposite and adjacent does change. Ready? Sweep the theta. Now draw an arrow across from the theta. That's opposite. And your adjacent means next to. Let's try another one. Our theta's here now. Notice it moved. Trace the right angle. The right angle points to the hypo always. That never changes. Sweep the theta. Now draw an arrow opposite of the theta, and that's called the opposite side. And then the side right next to it, that's not the hypo, that's called adjacent. Very important, you can accurately label these. So ready? I'd like you to go through here. And I'd like you to sweep that 32, and I'd like you to label the opposite, the adjacent, and the hypo. Take about 20 seconds there. There's your theta. That's the angle you're working with. Label. Okay, step one, there's your right angle, so y is going to be your hypo. Across from the angle, you sweep the angle and go across, and this is going to be considered your opposite side. And then next to the opposite side, or next to the angle, that's going to be considered your adjacent side. Opposite, adjacent, and hypo. Ready? You go through here, and I want you to label the hypo, the opposite, and the adjacent for both of these. Pause. Welcome back. Did you actually pause, or are you just copying right now? If you're copying, I suggest you stop and actually think for yourself and restart. Okay, your theta is here. So we start by doing the right angle, and we find our hypo. So this side is our hypo, and then across from the theta is going to be our opposite, and you physically draw that arrow. And next to theta, next from the angle that you're working with, that's going to be your adjacent. This one, our theta is 21. Our right angle points to our hypo. So this side is our hypo, the y. The opposite of 21 is A, and that is going to be our opposite side, opposite of the angle you're working with, which we are labeling theta. And then adjacent means next to. This is our adjacent side. That's not the hypo. Hopefully you got those down, because that's very critical. You're 100% accurate in labeling these. Now, one step further. Ratios. The ratio of two sides of a right triangle in reference to a certain angle. It has the following names. When I say certain angle, that's what we've been using, the variable theta. And those names we're going to get to in just a moment. Ready? It says sweep angle A. I'd like you to sweep angle A, to physically sweep it. Now from angle A, you're going to label the opposite, the adjacent, and the hypo. This is the opposite. Next to, this is the hypo. Excuse me, it's not the hypo, it's the adjacent. Getting ahead of myself here. This is the adjacent. And of course, across from the right angle, which you should generally start with, that's going to be your hypo. Notice I'm color coding these. I'm always going to use red for opposite, green for adjacent, and blue for hypo. Always. I will be consistent with this in class as well. And if you watch the color coding as we do this, you will notice that as well. Okay, so if I want to find the opposite over hypo ratio, in this case, my opposite ratio, I go opposite, that's a 3. My hypo is 5. So from here, you just get your calculator and do 3/5. I already know what 1/5 is. 1/5 is 20, or 0.20. So 3, this is going to be 0.6000. And you always want to take these out to the 4th decimal place. 1, 2, 3, 4. And you find these ratios. If you don't trust me, here's my calculator. 3 divided by 5 is 0.6, followed by zeros. Then we have the adjacent over hypo. So ready? Put an OH here. But in AH, we have adjacent over hypo. Our adjacent is 4. Our hypo is 5. Again, that's 4/5 and 1/5 is 0.20. So I have 4 of them. If you don't believe me, that's 4 divided by 5.8. Notice I went to the 4th decimal place again. So I have OH, I have AH. And then I have my last ratio here. And that's going to be OA. Adjacent, which is opposite, which is 3, over adjacent, which is 4. 3/4 of a dollar. Now these 3 ratios have names. The ratio of opposite over adjacent has the name sine. Little s here. The opposite over hypo. Adjacent over hypo has cosine. Tangent. Opposite over adjacent is tangent. And if you look at your ratios, sine is opposite over hypo, cosine. Adjacent over hypo. Tangent. Opposite over adjacent. That's where we get our acronym. SOH CAH TOA. This acronym is very important. It defines the 3 different ratios that we are going to be using, and we use the acronym SOH CAH TOA. Again, what this means is the sine of an angle theta. The ratio of an angle is opposite over hypo. That's called the sine ratio. The ratio of a certain angle adjacent over hypo, that's called cosine. The tangent ratio of an angle is opposite over adjacent, that's called tangent. So we get SOH, S-O-H, CAH, C-A-H, TOA, T-O-A. Take a moment and repeat this to yourself about 5 times. Pause and repeat. Welcome back. Did you actually repeat that to yourself 5 times? Or are you just skimming ahead on the video? Hopefully you did say that. It's very critical you have this memorized. So the sine of an angle is opposite over hypo. Cosine of an angle is adjacent over hypo. The tangent of an angle is opposite over adjacent. Again, it means ratios. Let me give you an example. I'm going to do one, and you're going to do one. It says here, find the required ratios in the given angles of the given angles round to the 4th decimal place. So right here, I want the cosine ratio of angle A. So I come over here. There's angle A. Step 1, you label opposite, adjacent, and hypo. That makes 24 my opposite. That makes 32 my adjacent. And the hypo is always across from the right angle. That makes it hypo. Start by writing the equation. We want cosine. So I write out the equation. Cosine of a theta angle equals adjacent over hypo. I'm going to pronounce it ka, 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 like a crow, cawing. Cosine, ka. Ready? So we want the cosine of angle A. So write cosine of angle A specifically angle A here, that's not the adjacent, equals the adjacent 32 over the hypo, which is 40. I'm going to reduce that. 8 goes in there 4 times, 8 goes in there 5 times, 4/5. 1/5 is 0.20, so 4/5, 0.8000. So the cosine of angle A is 0, in this situation, is 0.8000. You try these two. Pause. Welcome back. Tangent we're working with here. Tangent. We always start tangent of angle theta equals its TOA opposite. So of angle A, 8's going to be the opposite over adjacent, which is 15. There's your equation. Always write your equation first. And now I write tangent of angle A equals opposite circle plot over adjacent circle plot. From here, I'm just going to go 8 divided by 15 and round it to the 4th decimal place. 0.533 repeating. So this would be considered the tangent ratio of angle A in this triangle. Now with the sine ratio of angle Z, so there's Z, that makes 12 the opposite. That makes 35 the adjacent. And that makes 37 your hypo. Write the equation out. I want the sine ratio equals, and this is so. So it's O over 8. So my sine ratio is going to be my opposite, which is 12, over my hypo, which is 37. So I simply do 12 divided by 37, round it to the 4th. 1, 2, 3, 4, 32, 43. Now that's how you find ratios, the sine, cosine, tangent ratios when you actually have all 3 sides. This is called a right triangle flow chart. And this is on the back of your right triangle toolkit. So here's your flow chart. When you have a right triangle, and you have not a 30 or a 60 or a 45-degree angle, but something other than that, you start by labeling opposite, adjacent, and hypo. So to find the side of a right triangle, you determine what you have, need, and do. And you're going to make a proportion using sine, cosine, or tangent. Again, proportions. There's your 3 proportions. There's your sine proportion. Sine of theta over 1 equals opposite over hypo. Cosine. Adjacent over hypo. Cosine theta over 1 equals adjacent over hypo. Tangent. theta over 1 equals opposite over adjacent. So that way proportion, fractions. Don't freak out. All we're going to be doing ultimately is we're going back to this. I promise you, it's easy once you get through this lesson. But this is a lot of terminology. I recommend you actually pause and take 5 minutes and recap what you've learned so far and then restart again so you don't feel overwhelmed. Okay, now all these ratios are actually, there's giant tables that coordinate these ratios with these certain angles. For example, if you look carefully in your reference booklet, you're going to find this page. This page gives the sine, the cosine, and tangent ratio of all the degree angles, starting from angle degree of 1, going all the way to an angle degree of 90. So all these table ratios, I'll show you how to use this table in class. But you need to understand that this table has actually been stored inside your calculator. And I'm going to show you how to find that right now. So taking a look here, I'm going to show you how to find those stored ratios in your calculator. So right here, step 1, we're going to sweep our theta. We're working with 32 degrees. Now label opposite, adjacent, and hypo. That X is going to be your opposite. 15 is adjacent. Here's your right angle, so that forces Y to be your hypo. Now I'm going to do example 1 with you. We are going to find X. So in this case, we have the adjacent side. And if we're looking for X, we want the opposite side. Now notice I have an AO combo, although we don't write it AO. All right, we write it OA. Doesn't matter which way those go, but you always put the O first. I have an OA combo. So you come over here and you look and you ask yourself what goes with OA. Sine, cosine, tangent. Oh, OA, OA goes with TOA, TOA. So we're going to copy exactly that ratio down exactly as you see it. Tangent of theta over 1 equals opposite over adjacent. And it's always going to be opposite over adjacent. Never flip that. Copy it exactly as you see it. Now we start plugging it in. Watch very quickly. I'm going to go in slow motion here. Tangent of theta. Our theta is 32 degrees. So I write tangent 32 degrees. The parentheses around that whole thing. Over 1 equals opposite, which is X, over adjacent, which is 15. Very, very, very important. You do not touch a calculator until you get X all by its lonesome. Don't touch a calculator until X is by itself. Let me show you what we do from here. Like any proportion, you cross multiply. So we're going to write here 1 times x, which is just x, equals tangent of 32 degrees, put parentheses around that, times 15. Now it's very, very, very important you understand this. When I say tangent of 32 degrees, I don't mean 32 degrees. I mean the tangent of 32 degrees. A ratio of 32 degrees, which if you were looking on this chart, the ratio of the tangent ratio, that's the third column of 32 degrees, is right there. Okay? Or this is how you find it in your calculators. Those of you with the larger calculators, make sure if you have a TI 8384, you get in degree mode first. That's important. There's a video for that. Okay? Those of you with the smaller calculator, just do me a favor right now. Just touch the button tangent on both of them. If you see the word tangent, you're going to follow the directions on the right. If you hit the tangent button and you don't see the word tangent, you're going to follow the instructions on the left. Ready? To find the tangent of 32 on this left calculator, you're going to put in 32, then touch the tangent button and equals. So 32 tangent equals. That's the direction my calculator or my computer goes. Watch. 32 tangent. The rest of you, if you see the word tangent, you hit the button tangent, you hit 32, and then you hit enter. You should be getting the exact same thing. And you're going to take it to the 4th decimal place. Check your calculator. It should match mine. It's 0.6245. So what I'm going to do is I'm going to replace this with that. X equals parentheses 0.6245 times 15. Or if you have storage in your calculator, you can just leave the entire screen on there. I'm going to times by 15. And now I want you to go ahead and round to the 2nd decimal place. So that's going to be 9, your final answer, 9.37. So my final answer for x here, x is going to equal 9.37. Ta-da! Congratulations, you just finished your first honest to goodness trig problem. So that was X. No, this doesn't make sense quite yet. Let's do another problem together. Now we're going to find Y. We're going to start by labeling opposite, adjacent, and hypo, just like we've been doing. So from 32, this is opposite. This is adjacent. That right angle gives us our hypo. And we're going to shoot for Y now. That's what we're shooting for. We have the adjacent. In this case, we want the hypo. I have an AH scenario. And even if this reads like this, we would still say AH scenario. So you ask yourself, if you go back to your right triangle toolbox sheet, which is back here, what goes with AH? And what goes with AH is cosine. See that right there? That's what goes with AH. So it's cosine, as in so, toa. So in this case, if it's cosine, you get the ratio out, the proportion, which is cosine of theta over 1 equals adjacent. You'll always put adjacent on the top over hypotenuse. Now we circle plug check. Our theta is going to be 32, so we write cosine of 32 degrees, a parenthesis around that, the whole thing over 1 equals adjacent, which is 15, over our hypo, which is y. Do not touch a calculator until your variable is by itself, which it is not yet. You cross multiply. Bring it up here. Cosine of 32 degrees, keep parentheses around that, times y equals 15. Now, very important you understand this. We're not getting rid of the 32. We're getting rid of cosine 32. That's a single entity. So we're going to divide by cosine 32 degrees. I'm keeping parentheses around that so you understand that. So to find y, we're going to take 15 and we're going to divide by the cosine of 32 degrees, that ratio. Where do we get that ratio? You get that from your calculators. So we're going to find 32 degrees. You hit cosine, or some of your calculators, you hit cosine first, then 32. Either way, make sure your ratio matches mine. Try your calculator out. Okay? Once again, you either do 32 cosine or cosine 32. But make sure your decimal matches mine. See that on the upper left? We're going to take that to the fourth decimal place, which is 8480. So it's going to be 15 divided by 0.8480. And go like this, 15 divided by 0.8480. Take it to the second decimal place, so 17.67 is my answer here for y. 17.67. Hopefully you're starting to see a pattern here. Let's try this one. Here is our theta. Now we label opposite, adjacent, and hypo. Cross from 24, that's going to be our opposite. Next to the 24, that's our adjacent. And across from the right angle is always the hypo. Ready? Have, need, do. We have the hypo, the nature. I need, in this case, if I'm solving for x, I need the opposite. I have an OH combo. You take a look at your right triangle toolbox. And that toolbox is right here. This is in your reference booklet. Right here under the SOH CAH side, and we use this side, and we have a right triangle and an angle. On one side, we have an OH symbol, and OH goes with sine. OH goes with sine. So I take exactly this ratio. Exactly this ratio. And we're going to write that down. Sine of theta over 1 equals opposite, and opposite always goes on top, over hypo. Always write your equation. Now we circle plug check. Sine of theta. Circle the theta. We're going to write it down right there. Sine of 24 degrees. I put parentheses around that. Over 1 equals opposite, which is our x, over hypo, which is our 16. Do not touch your calculator until you isolate the variable. So we're going to cross multiply. And we get 1 times x, so that's just x, equals sine 24 degrees, parentheses around that, times that 16. Okay, now that you have x by itself, what you do? Now you can use your calculators and get that sine of 24. That sine ratio. And you're going to put it right there. So get your calculator out, make sure it matches mine. My calculator, I do 24 sine. Your calculator, you might be sine 24. Either way, watch my calculator and see if you get the same thing. We should be getting 0.4067. Are you getting the same thing as me? Okay, so now we go ahead and we're going to plug that in. That's 4067. And we're timesing that by 16. So here, since we're just timesing, I'm going to leave that entire ratio. That's fine. It doesn't make that much of a decimal difference. Times by 16. And lo and behold, we're going to take it to the second decimal place. That's going to be 6.5 right there. 6.51. And here's a quick little trick. If you do your math here, 6.51. And if you were to get an answer that's bigger than 16, you know you're wrong, because the hypo always has to be the biggest, longest segment. Ready? This page is completely on your own. Here's your graduation page. Do this on your own, all by your lonesome. Then grab a red pen and restart the video. Welcome back. Let's see how we're doing here. First, you label your opposite, adjacent, and your hypo. That would make this the opposite. That would make x our adjacent. And that means this 21 has to be the hypo. We take a look here. We have our hypo, the matrix, the hypo, and I need my adjacent, which is A. So I ask myself what goes with AH. If you look on your right triangle, AH goes with which is, we are right here in what's called the right triangle toolbox. Right triangle toolbox. And we're going to write this down now. So we've established this is cosine, so we write the equation, which is cosine of theta over 1 equals adjacent over hypo. Now we circle plug drag, cosine theta, or theta is 18 degrees, put parentheses around that, over 1, equals our adjacent, which we circle, that's our x, over our hypo, which is 21. Do not touch your calculators until that variable is by itself. That's 1 times x, so that's just x, equals cosine 18 degrees, that should be an S, 18 degrees times 21. Now we're going to find that cosine of 18 degrees. Put it right there. In your calculators, you do 18 cosine or cosine 18. Try to match up your ratio with mine. Make sure you're getting the same thing. It's going to be 0.9511. 0.9511, that's x equals times 21. That's times 21, so I'm just going to take that whole ratio here, times by 21. Round everything to the second decimal place. Second decimal place. It's going to be 19.97. X equals. Do not take shortcuts, please, I beg you. Actually set the timer on your cell phone for 2 minutes. And I'd like you to go back and review each page. Just take about 10 seconds per page and recap what did you learn from these pages.